Okay, so this isn't an entire ear, this is just the inner ear, right? That is really carved out of the temporal bone. And so it's divided into three parts. The part that looks like a snail, you can close the door if it's bothering you. And then the part that has all these weird alien-looking rings are the semicircular canals. Okay, all right. Now within the semicircular canals, you can see the gray semicircular ducts. Inside the ducts are the endolymph, and between the ducts and the bone that is carved out of the temporal bone is the perilymph. You don't have to know any of that for lab. You just have to know that this is a semicircular canal. Or I could put the tape on it and ask you to tell me a function. And what would you tell me? Balance and equilibrium. That works for me. Okay? Really what it's always telling you, no matter how you have your head tilted, it's telling you where your head is in space. And that is essential for balance and equilibrium. Okay? All right, so each semicircular canal has an enlarged bulb. Okay? So this is where that crista ampullaris is housed, with those little stereocilia sticking up into the cupula. And that's when those stereocilia get bent, then that's how sensations are projected along this vestibular nerve back to your balance and equilibrium centers in your brain. Okay, all right. So if I put the tape on here and ask you what it was, then you would just tell me that that was the ampulla of a semicircular canal. Okay, so there's different ampullae in your body. So I was just teaching the ampulla of the oviduct today to the 202 class. So you have to always say ampulla of what? Ampulla of the semicircular canals. Okay? Or I could ask you its function, and you could just tell me balance and equilibrium. Okay? All right. When I look in the vestibule and take away the outside of it, then I can see the two sacs, the utricle on top and the saccule on the bottom. And they also function in knowing where your head is in space, as well as the sensation of linear acceleration or vertical acceleration. And these are the structures that hold the little maculae that are the structures that have stereocilia embedded in a gel that has otoliths or rocks. See all of these nerves going towards this vestibular part of the vestibular cochlear nerve to supply proprioception information to the utricle, and this is the saccule. Okay, I remember it as the United States against the aliens. Okay, the U.S. against the aliens. So that's just easy to remember for me. And then this is the cochlea, and if I take the cochlea apart, I can see that it's just a bunch of cinnamon roll wraps of all of these cute little scala vestibuli, scala tympani, and cochlear ducts, right? And how did I know which was which? Because all I have to do is find my tectorial membrane. And my tectorial membrane is just going to stick out as a shelf above this spiral organ of Corti that sits on the basilar membrane. So that's how I always tell where I am if I'm looking at a section of the cochlea. So if I just put it on the cochlea, then you would tell me that it was the cochlea. If I ask you the function, you would just simply tell me what's the function of the cochlea. Hearing, right? That's it. That's all you have to say. And then this right here, what if I put the tape right here? What's that? The cochlear nerve, right? So that's it. So I want to show you, here is my cochlea, and here is my vestibule with the utricle and the saccule. Here's somebody has put the blue on the vestibular nerve. I could put the red on the cochlear nerve, okay, coming from the cochlea, or I could wrap tape around the whole darn thing, and if I wrap it around the whole darn thing, that's vestibular cochlear cranial nerve 8, okay? But if I do them separately, that's the blue is the vestibular nerve, the red is the cochlear nerve. Together they are vestibular cochlear, okay? All right. So I think that's all that I could ask you about this model. This is a really oh no, I could ask you the windows, okay? So on the bottom, there is an oval window and a round window. And I'm just going to tilt it so that you can see them both, I hope. Okay? All right, so my stick is the same semicircular canals. I have the same vestibule. I have the orange tag is on the utricle, and now my stick is on the saccule, okay, of the vestibule. And what's the function of those structures? balance and equilibrium, right? That's all it is, okay? And if I go, if I look, I can see the stapes that is going to connect to that oval window. So that means this one down here on the bottom, I often ask it there, that is the round window, okay? All right, so that's the round window, okay? So this is my stapes, so I know that this has been broken. Let me turn it so that it's gonna at least partly fit, okay? So that's how it's supposed to go, right? Okay, so where those little auditory ossicles are is my middle ear cavity, right? So that means this one right here is my incus with the, you know, it reminds me of the helmets that the people who speed skate wear, okay, to give them good aerodynamics. Just go like that. This is the incus, but the bone that actually articulates with the tympanic membrane is the malleus, okay? And it is mallet shaped, okay? So this is the malleus, okay? The one with the ski, you know, the speed skater helmet thing is the incus, and the stapes fits into the round, into the oval window, okay? So what if I ask you what the function of the tympanic membrane was? So it just transmits the energy of the sound waves to the auditory ossicles. That's all it does. Okay, so sound comes in your ear. The external acoustic meatus directs the sound waves to the tympanic membrane. The tympanic membrane vibrates back and forth and transmits that energy to the auditory ossicles, right? Okay, that's all it does. So it's not like you have to memorize, you just have to think about the process of hearing, right? I'm going to find this tectorial membrane. Okay, so I'm going to find the tectorial membrane, and that's going to orient it for me because I'm going to put this tectorial membrane on top of the spiral organ of Corti, and then that's the proper orientation for figuring out these different ducts. Okay, all right. So on top is my scala vestibuli, and so this is my vestibular membrane. Okay. On bottom is my scala tympani, and this right here, this pink layer, is my basilar membrane. Okay? The tectorial membrane is part of this bony shelf. It's part of the bone of your temporal bone, and that's why this tectorial membrane is so immovable. Okay? So when I set up sound waves in my scala vestibuli, and that makes my vestibular membrane go up and down, and then that energy makes my basilar membrane move up and down, then that pushes these little hair cells, and this model even has cute little hair cells on it, okay? That pushes those hair cells up into that tectorial membrane and causes them to kink, okay? And then that's what allows neurotransmitter to be released onto these first order neurons. See how they're a bipolar neuron? Okay, so these are the first order neurons of my cochlear nerve. That are going to go back to my medulla oblongata, synapse on the second order sensory neuron, cross over and go up to the thalamus, and then their third order sensory neuron is going to go out to the primary auditory center in my temporal cortex, right? Okay. To me, hearing is just such a magical thing. But the deal is that these little hair cells with their stereocilia, if you destroy them with loud noises, they don't ever grow back, okay? Maybe in your lifetime we're going to get, what I could do is I could take this tape and I could put it over this whole thing and say entire structure, and you would tell me spiral organ of Corti. And I almost always ask that on a lab exam, okay? Almost always, okay? All right? If I put the orange tape right there, what would you tell me? Tectorial. The tectorial membrane. And if I put it right here, what would you tell me? Vestibular. The vestibular membrane. And if I put it right here, what would you tell me? Basilar. The basilar membrane. Okay. What if I put it right here and said area? Media. That's the scala media or the cochlear duct. And this is the part that has the endolymph, because this is the part that has the hair cells, right? So when they kink, all that potassium ion rushes into those cells, and that's what causes them to release neurotransmitter onto this first order sensory neuron. Okay, so I could put the tape right here, and I could say, what's that? And what would you tell me? The cochlear nerve. That's all it is. Okay, taking